Now, for this previous video, you will observe that this small r here, which is the radius of the Amperian loop, is actually greater than the radius of the wire. So you can see that what this one is for what? Field outside the wire. This r here is bigger than this r. But let's look at the magnetic field inside this wire. And remember that, look at it, this is the whole of the wire here. Are you together? That is, if I'm considering this from the top, where the current is coming what outward like this. Now, I want to consider the magnetic field inside this wire. That is, if I'm drawing that, if I want to consider inside this wire this way, inside this wire. So what will I do? Pay attention. For me to get the magnetic field, what will I do? I will consider an Amperian loop. Look at it. Here, I want to get the magnetic field inside this conductor. So I will draw my Amperian loop. You see this one here is called the what? The Amperian. It's called the Amperian what? Loop. Why this is the what? The conductor, which is the wire. Now remember, the radius of this Amperian loop is small letter r. Why the radius of the wire is what? Capital letter what? R. Now, how do we solve this question? Remember, we are still making use of the what? The Ampere's law, which is the what? The line integral along this what? This closed path of B dot dl equals to what? Mu naught of the total current what? Enclosed by the Amperian loop. Now, if you observe, you see that what? For this part here, the Amperian loop encloses all the current inside the what? Conductor. But here, the Amperian loop is actually inside this conductor in a way that what? It did not enclose all the current inside this conductor. It just enclosed some parts. So what will I do? Let's pay attention. Now from here, you know that what? After evaluating this integral from here, everything, I go with b times 2 pi r equal to what? Mu naught of I what? Enclosed. Now, again, the Amperian loop inside this what? Wire did not enclose all the current. So how do we know the amount of current that is being enclosed by this Amperian loop? What do we do? You take note of the fact that what? Look at what I'm going to do. That the current density is a what? Is a constant. And what is current density? Current over area. Now, I will say the current density inside this Amperian loop is equal or constant, is equal to the current density outside this Amperian loop, that is inside the wire here. Now let's go. I'll say the current enclosed over what? Remember that what? The current enclosed must be inside this Amperian loop here, which is this, over what is the area inside this Amperian loop? That is what? Pi r square. That is pi r square, and that will be equal to what is the total current enclosed by the whole of this wire? It is what? I. All over what is the area of the whole wire here? Pi r square. So this is the current density, current over area. So I'll do it for the one enclosed, then on for the one what? Like outside the whole of the wire. I will explain again. Looking at this part, you observe that what? The Amperian loop, the Amperian loop enclose all the current inside the what? Conductor. But this part, the Amperian loop is actually inside the conductor, in a sense that this Amperian loop did not enclose all the current inside this what? Conductor. So we need to get the amount of current enclosed by this Amperian loop out of this I that we have here. So from there, I'll use the idea of the current density and get it this way. So from here, I can say that, okay, my current enclosed is equals to what? Pi r square over pi r square times I. And this is the amount of current what? Enclosed. Exactly. See what I have here now. Now from here, I will now go back to my what? Formula for what? Ampere's law. So what will I have? B times 2 pi r equal to what? Mu naught. My I enclosed, I can still replace that. Let me just use this. Pi r square over pi r square times what? I. And this is what you can use. So from here, you can decide to. So I can say B equal what? Mu naught over 2 pi r, then times what? Times pi r square over pi big R square, then I. So this is it. So looking at this, pi r, we take care of pi r. So from here, I have B equal to what? Mu naught I over 2 pi r square. I'm still having 1 r remaining, so let me just put the r here like this, r. So this is how to find the magnetic field inside a wire. Why this one is what? Outside the wire. So this one is what? Inside. This outside. And this is what? Inside. So using the Ampere's law. So that is the derivation. So thanks for watching. Goodbye.